I've been in the industry for about 4 decades now as a freshwater biologist. I've been in the ocean a little bit, but most of the work I've done here is on the coast. Currently, the area that I cover is the Queets Basin, the Quinault Basin, all the Chehalis Basin, and I've had the pleasure of working all the Willapa Basin as well. So you can tell it's just a small work area. To give you an idea on size, we took those streams and we put them end to end. We can go from Aberdeen to Pensacola, Florida, and back. It tells you how large these watersheds actually are when you end them stream to stream. Now, we don't cover all those watersheds because, you know, we physically can't, and there's not freshwater mussels and lamprey in all those watersheds. But that gives you an idea how big these watersheds actually are that we have to oversee and kind of manage. They don't all have salmon and steelhead in them, but we have to decide how many fish are coming back to these particular areas. But that shows you how big this water body is. So when we look at comparisons between watersheds and things like that, we have to sometimes use that in comparison of linear miles or things like that, and by species. As you know, some people say, well, Kurt, why are you giving a talk about lamprey? Because you're a salmon steelhead biologist. Usually in the industry, we always talk about the sexy ones. I mean, these are the commercial ones, the salmon, the steelhead, the cutthroat trout, bass if you're on Eastern Washington. There's bass in the Chehalis. You always talk about these ones that have an interest basically for a sport industry, a commercial industry, or that you have a particular interest in as well. But a lot of times you see these too as landowners, live in your backyard. You see these animals a lot of times that you don't see these other ones that we're going to be talking about today. I mean, these I would say are some of my top on my list of species of preference because these are the ones that you just don't hear much about and they really need to have a voice. And not speaking for teal, but you find that to have a voice, we're the ones that have to bring that voice up. And that's why I appreciate you being here today, because you could be doing a whole lot more things today than being here today. So it shows that you have an interest, a passion for your watershed or these particular animals to be out here of these animals. And I was going to take you down to the river, but if Teal has some stuff he could talk about up here, I can let him talk about that as well. Because I'm going to take you down to the stream and actually show you the life history at the stream level, not up here. The size of a Pacific lamprey is this big. In my spare time, I just sew. Spare time while I'm watching Netflix. No, this is actually from Bonneville Dam. It gives you an idea for demonstrations what the size of the animal is that comes through here. So they're about this size. So you can see the comparison between a brook and an adult Pacific. The ones on the Columbia are a little bit larger than these. They come in at a gray silver color, and they change color when they're in their spawning color. So as far as lamprey coming through here, remember I said it was Lampretta tridentata. The tridentata meant the 3 cusps. Lampretta means rock, is a Greek name for rock suckers. So 3-tooth rock suckers. I mean, that's kind of a nice name to have. Especially when you have a face that only a mother could love. So it's kind of a bad animal. And it has no commercial really value to it. So the unfortunate thing, kind of like freshwater, it has no commercial value. So it's really on the pecking order getting funds and all this. It's unfortunately been the bottom. As far as research, it's been the same thing. Our salmon steelhead have always been to the top. They've always getting the funds and things like that. When we look at historic databases and things like that about the population, we've never really known a lot about these animals, freshwater mussels, crayfish, all this, because we just don't know that much about it. We don't have much science. We know a lot about fish. We just don't know a lot about this because we haven't done much research on it, because we don't have the funds to go look at these animals.
Are you going to talk about how they latch onto salmon and go out to sea?
No, we're going to avoid that part because they never do that.
Well, has anybody ever caught a salmon with a lamprey attached to it? They must have, but you never see that or hear about it. At least I haven't. So what's with that?
So let's go into the life stages of lamprey. So as an adult, so what phase you want to start with? Juveniles or adults?
Start in the beginning.
The chicken or the egg? You want to start with adults or juveniles?
Adults.
Whichever, go for it.
Okay, well, since you guys are holding
Since it all
shovels,
comes around again.
let's just start with adults. Okay, so as an adult, they come up and they build these reds. And I'm going to show you what reds look like since you guys got pouring glasses on. Okay, so come on over here. I'll show you what they're doing. They come into the river system and they're going to put their eggs in the gravel because there are particular eggs that they have to bury them. So with the lip moving itself. Once they hang on to the rocks, they can hang on to it. They can do a little tail wagging with it. There's very minimal of the siltation that they're moving with their tail. So most of it's selection with the rocks. In other words, I can go into these rocks and I can pick them up and I can move them around to where I want them to. Then I'm going to move the couch over here. No, I want the chair to go over here. You see this battle between the male and the female. I'm moving these rocks around, but I'm going to select the nest that's here. They're moving this with their lips. You know, they can move up to 20% of their body weight with just their lips. And I asked kids at a school one time, I said, so if you weighed 100 pounds, how much would that be? They couldn't figure it out. I said, okay, 100 pounds, 20% of 100, what is it? 15? 30. The guy goes, nope, stupid, it's 40. Okay, so it was 20% of their body weight means they're moving 20 pounds. Now, for a guy my size, that means I'm moving 40 pounds with my lips. That's a drift boat anchor. That's amazing that they can do that. Basically, they're coming into an area, they're selecting it out. They can only select a particular size that's going to do with their lips. They're going to move it to the side, and you're going to find out when we do this exercise with a broom, with the plungers, and with my shovel, the difference of what steelhead can do and what lamprey can do. But they're moving and selecting it, the size selectivity, and then they're going to spawn together. Once they spawn, ready to spawn, she'll sit here like this. He'll put his mouth on top of her head. He'll coil around here, squeeze her eggs out, and his sperm will go out. She has 100,000 eggs inside of her, and she'll do this several times. Now, there's not pairing, there's multiple males and females sometimes in the same nest that goes on. Once they're done spawning, they'll go back and put the eggs on top. There's a little bit of elasticity to the egg, so it'll stick to the rock, but they actually have to bury it to keep it down inside the nest itself. So this area right here is a typical campfire looking red right here. And you notice in the bottom that there's a big enough rock in the bottom, they can't move there with the lips, but they take everything around it as well. Also, you find with the toilet plunger, there's certain small rocks they can't move because it's too small for them, they just can't pick it up. Now, if I was a steelhead, the difference between a steelhead and a lamprey would be, if I'm digging, here's the top end, there's a pocket. I'm digging from this way down here, I'm moving upstream, and I'm using my tail. In the case of our broom ladies over here, if I'm using just a broom, I'm not being selective. I'm just using the tail, I'm digging like this, and all the gravel's going downstream except for the big rocks. And my eggs are being left inside a pocket that's inside here because I have to bury my eggs, otherwise they're going to float downstream.
With the lamprey, is this an annual thing?
This happens annually, and it happens from the March through June time period that you see the adults. If any time you see bald eagles in trees during the springtime, it's because you have lamprey on the riffles right here. Sometimes there's a steelhead out here, but if you see, that's when the eagles show up because of the high caloric content. They will come out here and grab the lamprey versus grabbing a steelhead. The other one is, it's interesting too, is when lamprey are babies and they are born, they're born blind until they leave and they actually get eyes. But when they come back in, they have eyes coming up, but by the time they spawn, they're blind again, so they can't really see. So anytime you see adults like this on top of a red when they're building, they can't really see you, they can only see shadows. So here, they decide they're going to leave the springtime, they're going to leave the river system, turn into what we call a lamprey smolt. And in that smolting time frame, you're blind, you're a filter feeder. You then all of a sudden change in several months to then forming eyeball. You have a silver color to you, and then you start forming that tridentata mouth formation with that sucker oral disc on it. Because as you're going downstream in that couple month time period, you're thinking, hey, I can't wait to get to the ocean, because now you become a vampire.
How big are they at that point?
What's that?
How big are they?
They're leaving it at probably about that big. So if you see that little juvenile guide in my box, you'll get an idea what they look like, because they're right now in the confusing stage of being a brook lamprey or a amiseed at that time. They're very small, and sometimes you can only tell by looking at the tail the difference between the two, but they're very small when they're leading. They have that silvery color, but they're also on a downstream migration, because I'm going to go to the ocean like a coho smoke versus a western brook who's going to stay here its whole life. It lives here its whole life, doesn't even leave, and only will stay at that stage right here.
So what triggers what triggers them getting out of the sediment and onto a...
It's just it's that trigger of smoltification, just saying, is it 3 years or 5 years, whatever. Okay. It's just saying, hey, I've got to my certain size, okay. I've got this thing, I need to go, yeah. And it decides to go. And
how large are they when they decide to go?
They're just little guys.
And they've been in the mud for 3 to 7 years?
Yes.
Yep. Today, so I'm going to take off my brown hat, but I've been there about 12 years. I'm here just for you today, this community, this river, the species we're going to talk about today. So above and beyond the fish and wildlife hat stuff. But I've been there, I've been working kind of aquatic conservation about 20 years, so my work and my presentation is only going to be half as good as Kurt's, because he said he had 40 years, so lower your expectations for me here. But I'm here to talk a little about something even a little less known, maybe a little less sexy than the lamprey, and that's freshwater mussels. So Kurt just talked a lot about razor clams, which are delicious and a really important part of our nearshore community and recreational and commercial harvest for shellfish. One of the first questions I get about freshwater mussels all the time is, do they taste good? And the answer is no, and also I don't know, because Kurt was talking about health standards for eating shellfish and how they filter food. So that's also true for these, but nobody's monitoring what's in there. So it's just more questions about eating mussels are fine, but I'd say don't eat them because we don't know what's in them and they're filtering all the time. So I wanted to talk about, I guess, 3 or 4 major topics today. So I'm going to list them out. So if I don't tell you about them, you can ask me about them because I ramble a little bit. So one, I know a lot of people are wondering what a freshwater mussel is, or freshwater clam. What makes it different from our marine clams? Kind of what's going on with them too, because you don't hear much about them. Maybe you'll hear news flashes from back east or something like that about freshwater mussels. I want to make all of you experts in freshwater mussel ID today. So you can leave here being experts in things people don't know about. Kurt's going to tell you all about lampreys. I'm going to make you all experts in freshwater mussel identification. When you leave, you're going to see some of the regional experts on freshwater mussels. I was going to talk a little bit about why they're important in the environment and the ecology of freshwater mussels, what makes them so cool, and why it kind of sucks to be a freshwater mussel sometimes because they just can't move at all. Kurt was talking about his fish. In and out. Freshwater mussels, for the most part, most of their life, sometimes up to 100 years, they're going to be like right about here. That's about their turf. So they don't get to move around a whole bunch. They'll move around a little, but not too much. So if you get bored working in your office or sitting around at home, sometimes imagine about 100 years of sitting right there. But the river's moving by them, so it's not that dull. There's a lot of stuff going on. They get to see the river coming to them. All right, so as Kurt mentioned, we're doing a lot of Zoom, so I'm still kind of in Zoom, Teams, PowerPoint frame of mind. So if I miss something or things aren't coming out clearly, please let me know. So freshwater mussels. So I have a couple pictures of freshwater mussels over there, but they're bivalves, they're mollusks, they're relatives to your slugs, your snails, your razor clams. Help me out, Kurt. What's another great mollusk out there? Geoducks, limpets, all that, all mollusks. These are bivalves, so bivalves just means 2 shells. So 2 cells, bicycle, bivalve. The valve means shell, essentially, just like Kurt's razor clam. And what really is the most interesting separation between our marine shellfish and the freshwater shellfish is their life cycle. So you probably know clams just kind of broadcast spawners. They broadcast their gametes out there in the ocean, things swirl around and they settle out. Freshwater mussels, a lot of them live in rivers, and you think about that broadcast strategy. Which way is the water always going in a river? Downstream. So that's not a very good, it's oh, hooray, there go the kids. Man. But you see freshwater mussels all up into the foothills and the mountains and stuff like that. Does anybody, except Taylor, Kathy, Maybe Kurt, anybody have any guess how mussels go upriver?
On the feet of ducks.
Ooh, yeah, some freshwater clams. Actually, that is very true. We actually have some freshwater bivalves up in alpine lakes. But good guess, but not ducks this time.
Fish?
On fish, right. So they ride the fish school bus upstream. So what she said is very true. A little different group of animals, freshwater clams. There's fingernail clams, and some other species do hitch rides on duck feathers. So you get up to alpine lakes, and there'll be little tiny clams up there. What the heck? This is like below a glacier. How did it possibly get there? So yeah, there are some airborne mollusks out there. You do see clams flying up into the mountains, but these are hitch and rides on fish. And not so a little bit of the life cycle. There's a really great diagram there, and I have some handouts. But essentially, there's these blind little clams in the bottom of rivers that have to get their juveniles upstream. And they do that a lot in the east to some really fascinating mechanisms. They actually grow like lures, or they change their body shape to look like a fish. So larger fish will come up and like bite them, and they'll release their gametes, or their glaucidia is what we call them, onto glaucidia. Good vocab word. That'll come up at a trivia night at a bar someday, I'm sure. You're like, what do you call a juvenile freshwater mussel? And your team will get it because you will know the term glaucidia. So remember that. It'll be worth something someday, I promise. So these little glaucidia, or baby freshwater mussels, when a fish swims by, sees this little kind of crazy lure that the mussel makes, they will bite onto that and just get an explosion of baby mussels like right in their mouth. And these little baby glaucidia, a lot of times they have little beaks or teeth, and they'll snatch onto the fish. A lot of our mussels are gill or scale specialists, especially the most common one. They'll clamp onto the gills. I don't have gills. They clamp onto the gills of the fish, and they're like little baby vampires. They're actually sucking nutrients from salmon. And there's been interesting studies looking like, do these mussels are they detrimental to our native salmon and steelhead and stuff like that? In natural conditions, the answer is usually no. There's lots of little vampires on them, but they're really tiny. They're just stealing little nutrients. So they're on these fish. The fish are swimming upriver. And these are little fish. They're not on like the giant chinook, the chum, the pinks that are coming back on. These are on the juvenile salmon stages, so where they're still in the freshwater. These fish swim around with these little like vampires essentially stuck to them, like a school bus. So we have like a school bus full of vampires swimming around in our rural rivers, kind of like in Twilight, but a little different than that. So school buses, if the fish is a school bus, little vampires are our baby mussels going up. Great analogy, right? Makes a lot of sense. You see a Far Side cartoon maybe coming up right now. But that's essentially what's happening ecologically, is there's a little parasite on our fish swimming upriver. And you'll see a very cool association between our fish habitat and our mussel habitat. Because when those little baby mussels start maturing into juveniles, they'll drop off the salmon, essentially where the salmon want to be, and seed themselves. So that's how a mussel gets from here way up into the watershed, is on the salmon. So there's a really important tie between our native fish and their status and their population, and our native mussel population. So we have 3 genuses or 3 types of freshwater mussels west of the Rocky Mountains. And each one of those groups of mussels uses a different kind of fish. So the pearl shells we'll talk about like salmon. The floaters that we'll talk about, they like slower water, so they like different kinds of fish, or fin fish, or scale fish. We have a very rare mussel, which is one of the reasons the Chehalis is so awesome, because it's one of the few places west of the Cascade Range we have this rarer mussel. And that we don't even quite understand. Freshwater sculpins, maybe a couple of non-native fish. We don't even really understand which fish associations they're using. So a lot of cool stuff to learn about. Any questions? Because this is community group, right? I'm looking to learn things from you. I'll ask you guys questions later, like where are these mussels? So it's something we don't really know very well. Yeah.
So one of your statements earlier is incorrect.
Good.
Because they do move on the backs of on these fish when they move.
Yeah.
So they don't just stay in one place their whole lives.
That's true.
Yeah.
That's
So
right.
when
Just like
they're
me,
young-
they had a very exciting youth.
That's right. That's right. Yeah.
And then you have to stay in one place.
Yeah.
There you go.
But once they drop off, they don't move.
Correct.
That's where you're staying there.
Yeah.
But they do move as juveniles upstream.
Yeah, for a matter of months. Not a very long period of their mouth. Just kind of like my 20s or something like that. Really exciting. You have
And
to
they
go see
live
lots
to
of
be
things.
100 years old, some of them?
Yeah, some of our mussels, and I think, Kathy and you were there when I was doing my graduate work in this watershed in the Chehalis Basin, and looking at some of those. And some of the mussels that I was aging here were like 80 years old, so the big river. And it's really hard to do. It's like aging a tree, but a lot harder. It's like trying to, we'll talk about that in just a second.
So, what about flooding? Like if they get covered by silt, does that kill them?
Yeah, flooding can be kind of detrimental to them. There's a silt that can come down and cover mussels, but they're okay with that as long as it's not like a horrific mudslide or something like that. Normal siltation coming down the river. Actually, they'll kind of like they'll feel the water coming up, like the water rising, moving faster, and they'll say, time out. We're going down. We're going to hunker down in the mud right now or in the substrate, so they can dig themselves up and down a little bit. If they get buried a little bit, they can come back up a little bit as well. But catastrophic events like a big mass wasting event or big landslide, yeah, that'll hurt them. Also, they can get blown out too, and things get really flashy if the watershed is not a healthy watershed and rain happens. It's a high velocity, kind of like all the water's in the hills, then it's in the river, then it's out in the ocean. Those high velocity events, you'll see mussels kind of like in places mussels should not be afterwards. So big flood events in those rivers can move them around. Sometimes they'll make it back to a place. Most of the time they end up on the banks of the rivers kind of with the detritus and they will perish. That happens. That's part of nature. So that can happen from time to time. So yes, as you pointed out, they do move around sometimes. Sometimes they want to. Sometimes they don't want to, but it's usually involuntary where they're going. It's up to either like physical processes in the river or fish.
So, do only the vampires live, or do the ones that not find a fish, do they get the nutrients that the vampires are getting?
That's a great point. Like if there's not enough fish around, or if there's a miss, those juvenile Glaucidia will not survive. They have to have a host fish. That's part of their life cycle. So a lot of times if we have a fish barrier, like I know WFW, our agency spent a lot of money correcting fish barriers. We're talking about that as correcting fish barriers, correcting culverts, passage, blockage. That's for salmon, that's for steelhead, that's for fish, but there's a secondary benefit to freshwater mussels. We'll see these 100-year-old cohort mussels, and then a downstream barrier, and then a bed of mussels, and it's like 120, 30, 10. We got some teens in there, But upstream will just be 100 years old because they haven't been able to reproduce because it's been a blockage for salmon for however many decades it's been. So they can't complete their life cycle. There's resident trout a lot of the time to help with that. But sometimes they are completely cut off from their host fish.
I have two questions. The first one.
Kurt said only one, so.
Okay,
Yeah, ask her.
do any mussels use lamprey to move around? Is there a connection there?
I don't know. On the East Coast, there's ones use a salamander. I know that there's been some cool studies that they've looked at where lamprey are rearing, like the part of the life cycle Kurt will talk about, in mussel beds. They're really nutrient rich sometimes in our cold, clean, clear rivers, and I'll talk about that in just a second. But there are some benefits to these intact watersheds that could benefit lampreys when there's an intact mussel population there. So real quickly, freshwater mussels are cool. Back east, they're some of the richest places. East of the Rockies is the most biodiverse place in the world, and we have so many rare mussels back there. Actually, this year, my agency said 8 of those are extinct. So we have over 300 species, or we had around 300 species of freshwater mussels. That number is dropping fast back east. It's really cool. In the west, we have less species, but more range. So they have really narrow endemics. We have very broad ranging species, but they're contracting in the range. They're being less common here. And one of our mussels that I was so excited to find, that we're also excited to have in Chehalis, we're actually not seeing it anymore. So I'll talk about that kind of at the end. But it's getting exciting. Things are changing quickly, as we all know. But we don't really know enough about mussels to know why the things are changing for mussels. What mussels do in the river? So they're filter feeders like Kurt's razor clams. They suck water out. Yeah, so that's probably what everybody's thinking too. Is like,
Well, look at them at the end.
yeah. So we actually can demonstrate these mussels clean water. Like we have water treatment plants. We have settling ponds, stormwater ponds all over the place. Mussels are nature's stormwater water treatment plant. They're filtering constantly. But like I said, they don't move. So if there's like a spill or something upstream, or somebody dumps their oil in there, or the semi-truck flips over on I-5 and dumps in the Chehalis, fish can move. You know, that's terrible for fish a bit too. I'm not saying it's not bad for fish. Lamprey can move, salamanders can move, ducks can move. Mussels got to take it, man. They just have to take that oil spill. They have to take that fertilizer dump. You know, maybe one day it's a bunch of fish food that dumps in the river and it's the best day of their life. But they can't move from that spot. So not only are they cleaning our waters for us, they do this. Every gallon of water that goes down the Chehalis and New Altum gets a mussel suck. You know, they're sipping all the time, except in like high flow events. But also we can tell like kind of a chronology of what stuff has been in the river, because these things live so long. So you can take tissue samples or shell samples and see if something happened like 50 years ago, because they're still there. They were there for that. They may not have survived, but it's kind of cool. Mussels, because they're filtering too. You know, we always talk about cold, clean, clear streams, right? That's the mantra, cold, clean, clear for salmon. Mussels, there's not a lot for other things to eat if you have a cold, clean, clear, nutrient stream. So we were talking about lampreys, but mussels are always sucking in, always eating, right? What does everybody have to do when they eat? Like 6 to 10 hours later. They also have to defecate. Mussels do that too, so they can actually concentrate nutrients around mussel beds and in mussel beds. And the study I was talking about, I was like, hey, do lampreys grow better like when mussels are around? Because they kind of spit out these little things we call pseudofeces. You think about Cliff Bars, they're just like little nutrient packets of what the mussel doesn't with. It's a little nicer. Like they're just kind of like high energy bars that they spit out. So invertebrates, bacterial films, all that stuff can grow in those cold, clean streams around mussel beds because there's a little concentration of nutrients around there. So some of the mussel shells you'll see are sometimes covered in algae and snails and invertebrates, and there'll be cool little things tucked around inside them. So they're almost like little fertilized gardens in the mussel beds a little bit. I was going to talk about one more reason they're cool. I talked about how you could look at them because, like trees, when you look at tree rings, you can also look at mussel rings. But when you look at shells in just a second, you'll see those shells, especially our big river mussels, they get pounded all the time because they're sitting there in the river. Gravel's coming down, logs are coming down, so they're kind of beat up, so it's not as clean as a tree. We can kind of see every single year. We lose years sometimes because they get so beat up. So our estimates of age of mussels is always a little caveated with about this old, about how many rings we've seen in them. A real pain. I know I'm getting long-winded. I'm going to make sure I talked about everything I wanted to. I think lastly, and maybe the most fun thing to do, is learn how to speciate mussels. I used to let everybody take home all 3 species, or play with them, or throw them back here. But now one of the species is so rare in the Chehalis that I'm going to hold my 4 shells now, because I can't just go over to the riverbank and find a bunch anymore. So I said we have 3 species, and we have 3 genre of mussels. We have our big river mussels that are probably our most common, the western pearl shell. We just call them pearl shells. Big, thick shells, hard to crush, strong, tough mussels living in the river, filtering our rivers. We have floaters. They're called floaters because I'll tell you in a second. They're our still water, like our ponds, our reservoirs, our backwaters, our lakes are all full of floaters. And they have a real thin shell because they don't want to sink too much into the muck. You know when you walk into a nice looking lake sometime, you're like, this would be great, you're gonna jump the lake, and that first step, you're like up to your knee and like gunk, and you're like, oh, that's floater habitat. That's what they like. Why they're called floaters is sometimes when they draw down the big reservoirs on the Columbia to get ready for the spring melt, all the mussels can't go down as fast as the water, so they'll sit out there in the hot sun and die, and then they'll float up to the top as their shells fill with gases. So big sneaky mussels sometimes. It's part of an artificial system, it happens. The last one, our rarest mussel here, especially in the Chehalis and maybe in the West, is the ridge mussel. And so there's pearl shells in Russia, in Europe, throughout the northern hemisphere. There's pearl shells. We have the western pearl shell over here. Floaters, they're all over the place too. There's lots of different floaters. We can't even tell them apart. We don't even know how many different species they are. They all have that kind of genus or higher level, common level identification. Western ridge mussels, nowhere else in the world but in the Northwest. That's it. Up to the Okanagan River, Canadian Okanagan. They used to go quite a ways into California, now not so much. Now they're kind of like creeping their way up to Oregon. The Chehalis is super cool because it's one of the few. We got We just found a couple years ago pearl shells in the Willamette, or I'm sorry, western rid mussels in the Willamette. That was a big find. But until then, this was like the river with ridged mussels west of the Cascades until you got down to the Umpqua River in like southern Oregon. So this was a really cool river for having that ridged mussel.